Hello, and welcome to the Blender for Scientists beginner tutorial. Today, we're going start to finish, from downloading Blender, general use, all the way to producing a finished product, as well as some important comments on using your graphics in other software. Though this tutorial doesn't cover everything there is to know, by the end you'll hopefully have a good sense of how you can use Blender to take your scientific figures to the next level. I have a bit of a tendency to go fast, so pause is needed. I've also added timestamps to the description if you'd like to skip ahead. To start, head on over to blender.org and install the latest version. Generally, I advise working with whatever version is on the front page, though, as we'll see, certain features are only available in certain versions. Because Blender updates quite frequently, and some packages are updated by the community, not all versions are equal. For now, go ahead and grab whatever version is on this page, download it, and install it. If you're working with any remotely modern machine, anything from the last 5 years certainly, you should be able to run Blender. When you first open Blender, you'll be asked to choose a few settings. These can be changed at any time later, but to start, choose left-click select and set your spacebar to whatever you want. Mine plays animations. From here, save new settings and let's quickly discuss peripherals. Blender is best navigated with a mouse, one that has a middle mouse button. I tend to use a number pad as well, but the software has many ways to navigate without one. When starting out any scene, you'll have options for the type of file you want to start with. Different options will cause Blender to configure itself differently at startup. Most of the time, the general file is the way to go. The first thing we're going to do is go to Edit, Preferences. This window has all kinds of options, but there are only two I want to discuss right now. The first is Themes, which lets you customize Blender. If you have trouble seeing smaller fonts or points, you can change those settings here. If you have trouble seeing certain colors, you can do the same. It is possible to load in presets, and if anyone knows about freely available presets that improve accessibility, please put them in the comments. The next area we're going to is Add-ons. Add-ons confer extra functionality. Many are freely available directly in Blender. Others can be acquired for free or purchased. For scientists, as well as general Blender users, there is a basic set of add-ons that you should enable. To enable any add-on, simply check the box. Blender will remember whatever add-ons you've enabled, and if you update, you can import these settings later. A good starting list for add-ons is as follows: Node Wrangler, Atomic Blender, Add Mesh Extra Objects, Add Curve Extra Objects, Bool Tool, Modifier Tools, Import Images as Planes, and Tissue. And lastly, before we start with navigation, hover down to the little bar here. Right-click and enable the checkmark for Scene Statistics. This bar has all kinds of useful information for modeling and, in my opinion, should be on by default. Now that we have all of this done, we'll examine the interface and start making graphene. The basics of navigation in Blender are very simple. Mouse wheel to zoom in or out, middle mouse button and move to rotate around, and Shift plus middle mouse button to pan. These controls are also available on the side as the gizmo, the hand, and the magnifying glass. With a number pad, you can also switch rapidly between different views of your scene, such as front, back, right, left, top, and bottom. You can also view what the active camera views, and all of these can be accessed either through the number pad, the gizmo, or by hitting the tilde key just above tab on most keyboards, and then dragging your mouse to the desired view. Before we start modeling, I want to say this: save frequently. Sometimes Blender will crash. Sometimes any 3D program will crash, and losing a lot of work is never worth it, so use Ctrl+S liberally. Let's get started making our graphene object. We'll start by selecting the default cube with left click. Hit X and then confirm that you want to delete it. From here, hit Shift A and choose what you'd like to add. In this case, we're going to use a mesh, the simple plane. If you have extra mesh and extra curves enabled, you'll have all kinds of bonus options, but many scientific figures start with something simple. You'll notice that when we added the plane, it appeared in the outliner at the top right. It's generally good practice to label your scene and organize it. You can create collections by selecting an object, or multiple objects by holding down Shift, and then hitting M. This will allow you to either move the selected objects into an existing collection, or to create a new collection for them. In this case, I'll call this collection Camera and Lights. You can also come to the top of the outliner here, click this funnel, and enable the camera and arrow icon. Finally, as mentioned, it's a good idea to label the items in your scene. Either double-click the thing that you'd like to rename in the outliner, or simply select it in the viewport, hit F2, and then assign it the name you'd like. In this case, we'll call this graphene sheet. Up until now, we've been working in Blender's object mode, which lets us interact with full objects, either individually or together. To edit an individual object's underlying mesh, we select the object and hit Tab to enter into edit mode. To start, we're going to hit A to make sure we have everything selected. Then we'll right-click, and from this large menu, we're going to choose Subdivide. You can see I've added extra geometry to the mesh, and this has also updated in the scene statistics. More geometry can take longer to process, but we're far away from that being a problem right now. Now, when I hit Subdivide, I got a little menu for adjusting the number of subdivisions. I could change those here, but I can also right-click and subdivide again. A useful shortcut in this case is Shift-R, which will repeat whatever the last action was, and this works throughout Blender for pretty much any operation. In this case, I'll use it to add a good number of subdivisions. If at any point I'm unhappy with the number, I can use Ctrl-Z to change back. And then I can subdivide again and bring the number up to where I would like. It's worth noting that many of these smaller menus will be lost once you finalize any of the changes, so usually you want to make the changes before you click away. Some things are the same in both edit and object mode. For instance, in either mode, we can use G, R, or S to control the location, rotation, or scale of the object. We can also use X, Y, or Z after selecting any of those to lock the transformation in that axis. If you use Shift X, Y, or Z, you will lock that axis specifically, so changes will only occur in the other two. There are differences between changing in edit mode and object mode, and I'll demonstrate that now. With our graphene plane selected, I'm going to ensure that we are first in object mode, and then I'm going to hit N to open the side panel and show the Item tab. You can see I have information about the location, rotation, scale, and dimensions of my plane. Let's make the plane a little bit bigger by hitting S to scale. I could simply drag my mouse out to any size. I could also hold down Shift to get smoother and finer adjustment. This works for any transformation and for most slider menus in Blender as well. You can also type in numbers. I'm going to go with 5. Notice that when I do, the scale has changed. Many features in Blender will look at the scale, location, and rotation to decide how to perform certain operations. This is especially true for modifiers. If you make a change in object mode, the location, rotation, or scale will change. If you make a change in edit mode, it will not change. To demonstrate that, I've reverted to our original plane. I'll tab into edit mode, hit S to scale, and 5 for 5 times, lock that in, and tab back into object mode. This time, you'll notice that the scale has actually not changed. You can also update these values in object mode by hitting Ctrl-A and then choosing which of the transforms you would like to apply. This is often a source of confusion for beginners. So if something is behaving unusually, particularly with modifiers, try applying one or all of these transforms. Scale and rotation tend to be the most frequent offenders. Because we're here, we'll also quickly discuss the object origin. For any selected object, there will be a small yellow dot somewhere on it. This is the object origin, and often determines how things rotate or scale or move. In object mode, you can right-click after selecting an object and set the origin to a specific place, such as the geometry, the center of mass, or the 3D cursor. This little red and white crosshair circle. For now, it's enough to know the object origin exists and that transformations in object mode don't impact the origin. You can see that as I move, the origin moves with the object. But transformations in edit mode do impact the origin. If I tab into edit mode and move the plane again, you see the origin has stayed in the center of the scene. Though a bit more advanced, we'll also take the time to discuss pivot point and the 3D cursor. Pivot point controls where transformations occur relative to, and can be changed with the period key. By default, it's usually set to median point, but in certain cases, it is useful to change it to individual origins or to the 3D cursor. Whenever you add a new object, it is placed at the 3D cursor. You can also move around the 3D cursor as a pivot point and set object origins to precise locations using the cursor, which makes it immensely powerful. Two main ways to move the 3D cursor are to hold down Shift and right-click anywhere in the scene, or to use Shift-S and the associated pie menu. I do not recommend using the right-click method. It's hard to know where the cursor has gone in 3D. With Shift S, the main features are 1 for world origin, effectively resetting the cursor, 2 for moving the cursor to a selected point or object, and 8 for moving a selected object to the cursor. Together, these are extremely useful for all kinds of modeling. With all that, we still just have a plane. Let's turn our attention now to modifiers, which let you modify the selected object, exactly as it sounds. Modifiers can be accessed using this little wrench, or through various shortcuts. I mentioned before that different versions of Blender have different capabilities. Ideally, right now we'd like to simply go to our search bar or hit F3 for quick access and type in Convert to Dual Mesh. Convert to Dual Mesh is a feature of the Tissue add-on, and would give us a very good head start on our graphene. Unfortunately, Tissue is independently updated, and at least at the time of recording is not fully functional in the current release of Blender. Instead, we're going to achieve the same effect using modifiers. And that's something important to note. Many add-ons and many functions in Blender are simply combining other traits, and they're doing a little bit of behind-the-scenes work for you. But if you understand what's going on, you can do it yourself. You'll often see people refer to this as a default or possibly vanilla workflow. To add a modifier, simply click the object you'd like to modify, come to the Modifier Properties tab, click Add Modifier, and choose the one you want. I encourage you to explore different modifiers to see what they do. In this case, we're going to add a triangulate modifier, and then we're going to add a subdivision surface modifier set to 1 in the viewport. Blender will execute modifiers in the order they appear, from top to bottom, which will be important later when we add atoms to our graphene. Modifiers can also be hidden or enabled in both the viewport and the render. This is important as some modifiers, such as subdivision surface, add extra geometry, which can slow down performance on older machines or for large models. You can disable any modifier in the viewport to speed performance if you'd like by hitting the little screen icon. You can also disable the modifier in the render with the camera icon. These also work for collections. You'll notice the arrow that we mentioned before in the collections. This allows you to change whether or not something can be selected. So if you have multiple objects in a scene and are trying to select one and accidentally select another, turning the arrow on or off will make it so that the object in question can or cannot be selected. Finally, you can also control if a modifier will only appear in either object or both object and edit mode using this small toggle here. Modifiers represent part of a non-destructive workflow in Blender, meaning that you can continuously update them and change them without being locked into the final product. I'm personally very fond of this workflow, but destructive versus non-destructive depends on the project and your preference. Back to our would-be graphene. Now, on the surface, our plane hasn't changed very much. Even if we tab into edit mode, there seems to be little difference. In this case, we actually need to apply the modifiers. If you enabled the Modifier Tools add-on, you can simply select Apply All. Otherwise, you can apply the modifiers individually by hitting this arrow and selecting Apply, or by hovering over the modifier and pressing Ctrl-A in some versions of Blender. In older versions, there is often a button that says Apply Modifier. You also want to apply the modifiers in the order that they appear in the stack, as otherwise this can cause some interesting deviations from expectation. Now that we've applied all the modifiers, let's tab back into edit mode, and this time we see something very different. Plenty of little hexagons, the makings of our would-be graphene. Whereas Convert to Dual Mesh would have made the hexagons and cleaned quite a bit of this up, we'll have to do this ourselves, which is a good opportunity to learn some things about selection. To start, hit Alt-A to deselect everything. I'm then going to hit 7 on my number pad to come into a top view. In edit mode, you can choose if you'd like to select the verts, edges, or faces, the hotkeys being 1, 2, and 3 respectively. There are a lot of extra verts that we would like to delete here. The ability to quickly select whatever you want in Blender or any 3D software really is a very important skill. In this case, we'll hit 1 for vertex select and left click any vertex in the center of a hexagon. From here, we'll hit Shift G to select similar, and we'll select by amount of connecting edges to select every similar vert. Notice that when we did that, we got a little menu down here. This can help expand the parameters of the selection, i.e. select all the things with more than X connecting edges, or less, or within a certain threshold. For our purpose, this has worked nicely, and so we're simply going to hit X, and then we're going to choose Dissolve Vertices. We do not want to delete the vertices because we'd like to preserve the remaining geometry. Now, we'll repeat this for the verts between hexagon corners. Select any single vert, press Shift-G, choose Amount of Connecting Edges, and once more we'll hit X and dissolve the vertices. From here, we'll zoom out a little bit, and then we'll look at the center of our graphene sheet. I'll hit A to select everything, and then R to rotate, Z to rotate around that axis, and -45 to align the hexagons along the Y-axis. Now, to get everything just right, I'll hit S to scale, Y to lock it in just that axis, and then enter 0.6, which will give us nice, even-looking hexagons. Because we did all of this in edit mode, the rotation and scale have already been updated. If we had done this in object mode, we would have had to apply the rotation and the scale as we went, or it wouldn't work. From here, I'm going to hit 3 for face select, and Alt-A to deselect everything. I could now drag a box to select the faces I would like. I could also hit C and hold down the left mouse button to draw a selection I'd like. Rolling up or down on the mouse wheel after hitting C will make the selection larger or smaller. And once you have the selection that you're happy with, right-click to finalize. Another option would be to select a desired face and then hit Ctrl+ to expand the selection or Ctrl- to shrink it. If you find your graphene sheet isn't big enough, you would have to make a new plane with more subdivisions and repeat these steps. Given how long we've spent so far, that may seem daunting, but the original tutorial for graphene is only 10 minutes, and everything up to now takes less than a minute once you've done it a few times. For our selection, we want to make sure that we're not going to select any of these nasty edges. You can see if I press 1 for vertex select, I have extra verts here that I didn't remove. These would be problematic for some of our workflow later on, so we're going to make sure we don't choose any faces that contain them. Once I have my desired selection, I'll hit Ctrl-I to invert it, and then I'll hit X and delete faces. Finally, we have something resembling our graphene sheet. So now we're going to make it a little bit more interesting. I'm going to hit Tab to go back into object mode, come to the modifiers, and add in a wireframe modifier. In the modifier settings, I want to enable boundary, because that's going to fix the edge right here, which you can see is hollow. From here, I can change the size of the wireframe by adjusting the thickness. As I mentioned before, you can either enter in precise numbers, or you can hold Shift and drag to give yourself a little bit more control over some of these changes. In any menu in Blender that relies on numbers, you can also do math for precise changes, or enter in specific values. Once I have a thickness I'm happy with, I'll add a bit of extra geometry to smooth out the model. However, in this case, I definitely do not want to use subdivision surface, as that will add too much geometry, perhaps warp the look that I'm going for, and slow things down. Instead, I'm going to use a bevel modifier. I'll change the segments to 2 or 3, and depending on the version of Blender you're using, you may have to change the limit method from none to angle. I believe newer versions of Blender use angle by default. If I zoom in on my graphene, you can see it's now quite a bit smoother, and I can select the graphene, right-click, and choose Shade Smooth to further smooth that. If we look very closely, you can see the edges aren't actually fully rounded. To get the rounding, we need to lower the bevel amount. The right bevel depends on the thickness of the wireframe and has to be adjusted accordingly. I've made models of graphene freely available, and in those, the bevel value is actually mapped to the wireframe thickness, so it updates automatically. That type of customization is possible, but beyond the scope of what we're doing today. For now, it's simply enough to select the amount, hold Shift, and drag until you see changes in the wireframe. And something like this would be just about right. At this stage, if you really wanted to, you could apply a subdivision surface to get an extra smooth model, but it will likely slow everything down. In fact, I recommend disabling the bevel in the viewport to speed performance. We'll now add some visual interest to our graphene in 2 ways. One destructive and one non-destructive. We'll start with the destructive version. And before we do anything, we're going to hit Shift-D to duplicate our model, dragging it anywhere, and then right-clicking to drop it in place. Make sure you're in object mode for this, as duplicating in edit mode keeps everything as one object. This is going to be our backup object, in case we are unhappy with the destructive changes. If you're going to use a destructive workflow, it's always a good idea to have a separate collection of backup pieces at various stages, in case you need to make changes later. We'll do that now. To start with our destructive changes, we're going to grab our graphene plane, tab into edit mode, hit 1 for vertex select, and then hit O to enable proportional editing. You can see that pressing O has enabled the toggle at the top of the screen, and if I click this menu, I have all kinds of different fall-off options. Once I start any transformation now, move, rotate, or scale, you'll see that I have a little circle, and that the transform will follow the selected points, starting most intensely at the selected point and then falling off based on the size of the circle. You can adjust fall-off while editing by scrolling up or down on the mouse wheel. From here, I'll hit G, Z so that it's only moving up and down, and then I can adjust and create either a small hill or indentation. Try experimenting with different fall-off types for different effects. This works because the wireframe and bevel are applied as modifiers. If they were applied as geometry, this would be an enormous mess. So let's make a few hills and valleys, and then we'll look at the non-destructive approach. The benefit of a destructive workflow is that the model is very customizable. The problem is that if we want to revert back to a flat plane now, I'm largely out of luck, depending on the number of transformations or the complexity of the transformations that I've made. For a non-destructive workflow, we'll start by pressing H to hide our existing graphene sheet, revisualizing our backup sheet, pressing Shift-D again to duplicate this, and we're going to rename this one non-destructive graphene. I'll also press M and move this back to the main scene collection. This time, we're going to add a modifier, specifically a displacement. We're going to move this modifier to the top of the modifier stack, and in version 2.9 or onwards, you can do that by simply selecting these small dots and then dragging the modifier to the desired place. In older versions, you'll have to open a small menu here and toggle up or down to control where the modifier sits in the stack. To add a new texture for our displacement, we'll hit the New button here, and then we'll come down to the Texture Properties panel. Under Type, you'll see all kinds of different options, but I'm going to choose Clouds for now, and you can start to see the effect right away. It's a bit too fine and a bit too strong, so we'll make it more spread out. And to do that, I'll bring the size up to 2. If you try to drag, Blender will stop you at 2, but if you'd like, you can type in a higher value. Many menus in Blender have these soft limits built in, and once you've exceeded them, you can pretty freely adjust as you'd like. For now, I'm going to leave this value here. We could also return to the Modifier panel, and under Strength for displacement, you can adjust the strength to either 0 or 1, or values above or below. As I mentioned, this approach is non-destructive because I could remove the modifier, hide the modifier, or drop the strength to 0, or change the cloud's texture at any time to make changes to the appearance. This type of flexibility is often useful for exploring different designs or for creating perceived randomness. It's also very useful because properties such as strength can be animated. Now that we have our graphene sheet, let's go ahead and put some atoms at each of the corners of the hexagons. Blender has arguably 3 main sensible ways to place large numbers of objects at specific points. Those are particle systems, instancing, and geometry nodes. Particle systems offer more control than instancing, will work in most versions of Blender, and they are what I'm going to showcase here. Geometry nodes are a relatively new feature at the time of recording, but promise to be very powerful moving forward, and will likely eclipse this use of particles in the future. That being said, particles are very useful, and since they are more widespread through different versions, they're worth knowing. To start, select the graphene plane and tab into Edit mode. Press A to select everything, and make a note of the number of vertices. From here, tab back into Object mode, go to the Particle Properties tab, and hit the plus icon. There are 2 main types of particle systems, emitter and hair. Emitters will emit particles and are very useful for visual effects, whereas hair particles will place particles on the object, and that is what we want today. We'll start by changing from emitter to hair particles. We're also going to change the number of particles to the exact number of vertices that we recorded before, 219. For now, we're going to ignore the other options. We're then going to go to Source, and from the submenu, we'll change Emit from Faces to Verts. We're also going to uncheck Random Order, and we're going to enable the modifier stack. Right now, you can see we have a crazy mess of long hairs. If we go back to the modifier stack, you can actually see that the particle system has been added as a new modifier. What we would like in this case is for it to sit underneath the displacement, but above the wireframe and the bevel. That way, the particles will emit only from the verts on the corners, but will also be distorted according to the displacement. Now that we've done that, you can see that all of the hairs are pointing up. But in this case, we'd actually like to place a different object there. So we'll go ahead, deselect everything, hit Shift A, and I'm going to add in a simple UV sphere. We'll use the default settings, right-click to shade smooth, and press Ctrl 1 with the sphere selected. This will add a subdivision surface modifier of 1, and before I get going, I'm going to actually disable this in the viewport. Adding thousands or hundreds or tens of thousands, depending on your scene, of subdivided objects is very likely to slow it down considerably. I'm also going to take the time to just take our sphere and move it to the side, and to rename it Carbon Atom. With our sphere added, I'm going to select the graphene plane, return to the Particle Properties tab, and scroll down to Render. From here, I'll change Render As from Path to Object. I'll now scroll further down, and you can see I have options for the object I would like to choose. I can either click the box to see available objects in the scene, or I can use the eyedropper and select the object from the scene that I would like to use. Now, if the spheres appear far too large, you can adjust their scale either by changing the scale of the sphere itself, or through the particle system scale settings. I recommend using the scale settings in the particle system. It's worth quickly mentioning here that particle systems offer all kinds of additional controls. The ones I find myself reaching for most often are rotation, which allows you to control particle orientation, and density, which allows you to tell Blender exactly where to place particles using specific groups of verts. Rotation can be accessed by enabling the advanced options, and density can be accessed through the vertex groups at the bottom and assigning a specific vertex group. For more information on this, see my video on using Booleans and particle systems, which I've linked in the description. And now, we finally have a graphene sheet, complete with a nice flow and some atoms. We can adjust the size of the wireframe, the smoothness of the bevel, and the size of the atoms. At this point, you have most of the tools you need for basic modeling and navigation, and many of the other videos on this channel show how you can fine-tune particle systems for all kinds of graphics. Now that we've made our model, it's time to set up the materials to get the colors and look that we want, and to put it all together with lights for our final render. Shading in Blender allows us to customize the final look of our model before rendering, and advanced shading techniques can actually be used as a substitute for modeling in some circumstances. For the most part though, shading simply means applying a material to an object to give it a certain appearance. The materials we need for our graphene are actually quite simple, but we'll go through a deep dive on all the basics to give a good overview that should carry you through most tutorials. The first thing we're going to discuss is the views. Up until now, we've been operating exclusively in solid view. If you press Z, you can see we actually have 4 main view options: solid, wireframe, material preview, and rendered. Though we won't be using wireframe for shading, it's important to quickly say that wireframe is very useful for modeling and actually lets you see the underlying structure of the model. It's also transparent for selection, meaning that you can select both the front and back of an object in wireframe mode. For shading, the 2 views we're going to focus on are material preview and rendered. Rendered view shows you what you will actually see in the final render. Blender comes equipped with 3 rendering engines, but the 2 we'll discuss are Eevee and Cycles. To change between render engines at any time, go to the Render Properties tab and select the engine you'd like to work with. Eevee is the default and is a real-time rendering engine. If you're using Eevee, then the material preview and rendered modes will give very similar final products. You can set up the rendered view to look pretty much exactly like the material preview, which is very convenient for quick work. By contrast, Cycles is a path tracing render engine. If you're just starting out though, the main difference is that Cycles will give better glass, shadows, and general interactions with light, but takes much longer to render. It also opens up some impressive shading features beyond the scope of this video. Eevee is much faster, but better suited to simple cartoons, though it can be used to great effect with some adjustment. All of this is relevant because the choice of render engine and settings heavily impacts the way the final product will appear, as well as the work and time needed to get there. We'll start working with Eevee and transition to Cycles at the end to showcase the differences. To get started with materials, we're going to select our graphene plane and come down to the Material Properties tab. Simply click the New button and we'll get a default material. In most versions of Blender, this is a principled BSDF for bidirectional scattering distribution function. In the past, Blender relied on different types of shaders for different materials: glass for glass, glossy for metals, and diffuse for more matte looks. Most of the time, the principled BSDF will be the only shader you'll need, and the main controls are quite simple. We'll start by hitting Z and coming to Material Preview. We can then change the base color. You can use RGB, HSV, or you can adjust the color wheel to any value you like. If you have a very specific color you're after, you can also enter in the hex code. The other common controls for the principled BSDF are metallic, roughness, and transmission. Metallic is usually set to 0 or 1, which makes the object appear metallic. Roughness controls how reflective the object is, where 0 is a super reflective surface, essentially mirror-like, and 1 is a fully matte surface that doesn't really reflect anything. Transmission will let you make the material into glass, but only if the metallic value is set to 0. For most simple materials, controlling the color and metallic and roughness value, or transmission and roughness value, will get you the look that you're after. At this point, we've given our graphene plane a material. But we might also want to give our atoms a material, and there are a few ways we could do this. We could select the atom and add a new material. In this case, we'd like it to share a material with the graphene plane. And to do that, we're going to select our atom, then hold down Shift and select our graphene plane. You can see that the orange object here indicates that this object is selected, but the yellow around the graphene indicates that it is the active object. Whenever you have a multiple selection set up, you can press Ctrl L and make links between all of the selected objects and the active object. In this case, we're going to make links for the materials. This is very useful if you want to give multiple objects the same set of materials or modifiers. You can also add materials from the existing list. By default, Blender will delete materials that aren't being used in a scene. So if I add 10 materials to test out different looks and then exit without them being applied to anything, they will be gone when I get back. This is true even if you save, so watch out. To prevent this, click the small shield and Blender will preserve the material even if it's not being used. Materials, like objects, can also be named, and it's good practice to give them labels. To borrow a piece of advice, try to avoid naming materials after traits, such as colors, because you might decide later on that you prefer orange to green. Instead, try to label materials based on what they're being used for, so atom material or graphene material. Finally, note that if you apply the same material to multiple objects, updating the material will change all of the connected objects. The number of objects that share a material will be indicated by the little number right here. If you click this number with any object selected, it will make that material independent, so you could now change it freely without updating the others. You can see my graphene is now green and the atoms are blue. This can be useful if you're happy with all of the other parameters of a material but want to change one, such as the color. Strictly speaking, we're now going into a more advanced topic that isn't necessary for our model but might be essential for other cases. We've been editing our material in the Properties panel, over here, but we can also do that using nodes and the different workspaces in Blender. At the top of the screen, you'll notice different tabs for layout, modeling, etc., etc. These will configure the screen for a specific workspace. One of these is the shading workspace, and if I select it, it brings up a set of specific windows. I generally don't use the shading workspace because I prefer to customize my own. I'll return to the layout tab. And if I move my mouse to the corner of any set of windows, you'll see the cursor change to a small crosshair. If I hold down and then drag in any direction, I can open a new panel. If you try to drag in a direction that isn't possible, you'll get a little stop symbol. To close a panel, return to the same location and then click and hold and drag. You should see a big arrow appear. The panel will gray out slightly, and if you release the mouse, it will remove the panel. There are some rules about how panels can be opened or closed, but generally they close in the reverse order they were opened. Many people like to make customized workspaces with panels because they can let you see different views at the same time, such as wireframe and rendered, or from different perspectives. You can also adjust the size of the panels by creating one, moving between them until you get the double arrow, and then clicking and adjusting the dimensions. One thing worth noting is that if you accidentally drag out a panel and you're still holding down the left mouse button, just right-click. Right-click in Blender tends to reset any incomplete action. So if you move something and haven't released the left mouse button yet, right-click will return it to its original state. This is true for most things. I mention this because Control-Z does not undo panels, and it can be quite frustrating for people as they undo things in their scene when all they wanted was to get rid of an accidental window. Our two main panels here are currently set to the 3D viewport, but we also have an outliner open, a properties panel, and an animation timeline. The different pre-built workspaces simply use all of these. Right now, we want one 3D viewport and one shader editor. I'm going to simply go to the top here, click, and choose Shader Editor. From here, I'm going to simply hit N to hide this side panel, and I'll zoom in. Navigating in many of the other panels in Blender is the same as in the 3D viewport, so middle mouse to move around and to zoom in and out. With the shader editor open, we can now get a different view of our material. We'll grab the atom object, and we can see that we have this network of nodes. Right now, it's two simple nodes, but for more complex materials, you can add all kinds of extra nodes to control features. In this way, we can control the color, the metallic, the roughness, the transmission, and many, many other properties. I know I've said a few times that certain topics are beyond the scope of this video, but nodes and advanced shading are way beyond the scope of this video. For today, we'll use a simple example to show what they can do. Just like with objects, if I hover over this window and hit Shift-A, I can add in a new node. There are tons of options, but for now we're going to choose a texture node, specifically a Voronoi texture. I'll left-click to drop that in place, and then I'll add another node. This time, it's going to be a color mix RGB. Let's say I want one of these colors to be the one I'm already using. I can simply hover my cursor over the color, indicated here in the base color, hit Ctrl-C to copy it, and then hover to the box in the mix RGB and press Ctrl-V to paste that color. This type of copying and pasting from different boxes works through most of Blender, be that for colors, numbers, etc., etc. For the second color, I'll choose something different, such as red. And if I want, I can now plug this node into the base color of my principled BSDF. Nodes generally work from left to right, so this mix of colors is now going to control and decide the final color. You can see I also have this factor option, and I can adjust it either between all of color 1, blue, or all of color 2, red. If I now connect either the distance or the color of the Voronoi texture, it will tell Blender where to place both of those two colors on my object. I will go focus on the sphere for this example. In this case, it's a little difficult to see this with transmission, so I'm going to change the object to be fully metallic instead. As I mentioned, there are all kinds of other things we could do with nodes, and if you really want to know the inner workings of these, I highly recommend Arendelle, Ducky3D, and Default Cube here on YouTube. With the right materials, you can often avoid modeling complicated things, and if you use pre-existing image textures from websites such as cc0textures.com, it's a very easy way to turn a simple object into something you'd like, such as a rough metal surface, a solar panel, grass on a field, etc., etc. You can also use nodes to create very specific custom shaders, such as bone or perovskites, both of which have walkthroughs on this channel. But for now, that will be it for material nodes. There's tons more to say on this subject, but that is usually a full course in its own right. I'm going to quickly change everything to somewhat more sensible materials, and then we'll get back to the remainder of the tutorial. We now have our model and our materials, so it's time to configure our lights and background. Backgrounds for scientific figures are often transparent because the image has to be placed into a complete figure with text and annotations. To get a transparent background, come to the Render Properties tab, scroll down to Film, open the menu, and choose Transparent. This is true for both Eevee and Cycles. If you've been using Material Preview to adjust your materials, you might want to use that lighting for your final render. If we hit Z and come up into the render view, you can see this is noticeably different. If you want to use the Material Preview lighting, simply come to the World tab, click the little yellow box beside Color, and from Textures, choose Environment Texture. This will allow you to make use of built-in lighting in the form of High Dynamic Range images, or HDRIs for short. HDRI Haven is a great resource for these, and you can find all kinds of different options, but Blender comes with 8 built-in variants. And you can see those here by hitting Z, returning to Material Preview, clicking this little arrow, and then once you have one of these visible, click it, and you can see all of the options. Mine has several extras installed, but by default, Blender comes with the first 8. To use those in your final render, simply click Open on the environment texture, go to wherever you've installed Blender, and then what you want to do is find the data files, Studio Lights, World, and these are the 8 built-in HDRIs. Blender usually starts with the forest by default. And if I click this and hit Z and now come up into rendered, you can see the lighting is largely the same because I'm making use of the built-in lights. I find built-in lighting is generally sufficient for journal articles because custom lighting often introduces shadows that can be a bit distracting for a figure in a paper. If, however, you are intent on using your own custom lights, you can do that as well. In the 3D viewport, hit Shift-A and then simply add in a light. The main types that you're going to use for custom lighting are point and area. You can also move lights in much the same way as objects by hitting G to simply move them, and then R to rotate them around. You can also scale lights, and through their object data properties, you can adjust their intensity or color. You can control as well whether or not they will cast shadows. For maximum control, you'll want to set up your own lights, but for simple cartoons or articles, again, I prefer going with an HDRI, one of the built-in ones if possible. We're almost there. We have our model, we've given it materials, we set up our lights and our transparent background. Now we just need to get the camera into the right place. You can have multiple cameras, but Blender adds one by default to every new scene, and we'll use that. If you deleted the camera, you can simply hit Shift-A and add in a new one. If you have multiple cameras, only one will be the active one, and that one will be used to render. To make a camera the active camera, simply select it and then hit F3 and search for Set Active Object as Camera. Once you're in camera view, using either number pad 0, the tilde icon, or the camera icon over here, zoom in until the camera fills up most of the screen. From there, hit N to open the side panel, come down to View and enable Lock Camera to View. You can now navigate as normal and the camera will follow. Once you have a view you're happy with, uncheck the box or the camera will keep following you. Cameras also have extra settings such as focal length, depth of field, and others. Again, for simple cartoon figures, default settings will do the job most of the time. We can now finally cover render settings and create our final image. Optimizing render settings comes down to two main goals: rendering a good quality image and rendering it fast. There are excellent videos about optimizing these settings by both Blender Guru and Josh Gambrell on YouTube. And though I use much of what they say, we'll go through some basics here, and I'll link their videos for those who want more detail. To start, we're going to go back to Edit, Preferences, and this time we're going to come to System. If you see a GPU and CPU option here for CUDA, enable both. If you have a NVIDIA graphics card specifically, you can enable optics. From my understanding, CUDA is the more universal platform, so we'll stick with that. For render settings, we need to discuss some differences between Eevee and cycles. You can see right now that we're in render view, and we are currently working in Eevee. You may find videos saying Eevee is no good, and you may find videos saying it's fantastic. Eevee is fast, and I would say it is good enough for simple cartoons. If all you have is a simple stack or graphene plane with no shadows or glass, Eevee is usually fine. Cycles, on the other hand, is much slower, but gives you far more options and usually looks better. I use Eevee for test renders and animations when I need to render things quickly. I use cycles for when I want things to look good. As a general rule, Eevee for previews and cycles for the final product, especially if you're working with still images for figures. Regardless of which engine you're using, there is the question of resolution and file type. If we go to the Output Properties tab, under Dimensions, you can hit the little box here and see a number of different render presets. Higher resolutions take longer, but can prevent pixelation. I tend to use 4K UHD-TV for final renders. You can also set custom resolutions to change the size of the camera window. This is useful if you have a lot of blank space so you don't want to have to crop out later. Reducing the area you need will also speed up the render. In terms of the type of file to save as, you'll get differing opinions. I use either a PNG set to RGBA and 8-bit colors for standard everyday things. I also use a much higher compression than the default 15% that Blender assigns. This slows things down, but makes the file size much smaller. For images where size is no issue and it's got to be the best, especially if I'm editing it in Photoshop later, I use a 16-bit color TIFF with RGBA again. This is true for both render engines. In both cases, you want the A because it will enable the alpha channel so you can use transparent backgrounds. This tends to be very helpful for PowerPoint. The other common setting I want to discuss is color management, specifically the view transform. To access that, come back to the Render Properties tab, scroll down to the bottom, and you'll see Color Management, View Transform. By default, this is set to Filmic, and that is fine in the vast majority of cases. However, Filmic can prevent you from getting white, or rather, fully white, which is sometimes an issue. For instance, the default background on PowerPoint slides is fully white. If you use Filmic to render something white, it will appear slightly gray in comparison to the slide, whereas Standard will match the slide. If you really need something to be fully white, then change the view transform to Standard. If you run into this in a tutorial, they should specifically mention if they're using Filmic or Standard. With all that said, let's look at the specific settings for Eevee, and then we'll talk about cycles. For Eevee settings, come to the Render Properties tab and check the box for ambient occlusion. If you're using glowing surfaces, enable bloom, and if you're using glass in Eevee, you'll need to enable screen space reflections, as well as all kinds of other setup that we won't discuss here. Otherwise, we're generally just going to go to the Render tab, hit Render, or F12 as a shortcut. We'll let that go, and we'll make a quick note of the time it took. But before we render, we're actually going to want to go up and make sure that anything that we don't want to see in the final render is disabled. That includes our backup graphene sheet and our destructive graphene sheet. Because our atom is out of frame, we don't have to worry about that. So we'll go ahead, hit F12, and make a note of the time. You can see that our Eevee render finished very quickly, in just under 2 seconds. Cycles, on the other hand, can be accessed through the Render Properties tab, and has a number of settings to consider. Many features are actually only available once you enable cycles. However, for this video, we're only going to discuss the render settings. Right away, if you have a GPU, you can switch the rendering device to GPU. We can then adjust the sampling. Roughly speaking, a higher sample number will give you less noise and a better image, but will take longer. For most images, 200 samples will be fine. In some cases, especially with glass or highly reflective surfaces, you may want to reach for a higher number, such as 500. Be warned though that individual renders on some machines with cycles can go for hours, and if you max out settings, they can also be quite hard on your computer. So as I said, for most things, 200 will be fine. In more current versions of Blender, you can also open the denoising box. It's usually a good idea to enable this for the render. You can think of denoising as letting you get away with a lower sample count. Use the denoiser that best fits your machine. I typically use optics because my GPU is from NVIDIA. At this point, we're going to quickly drop down to the Layer Properties tab, and we're also going to check the box for denoising data. There are all kinds of other passes here that can be very useful for different things, and we'll do a little compositing after we render our model. Returning to the Render Properties tab, we're going to open Light Pass and lower the maximum number of bounces from 12 to 6. We're also going to change every value higher than 4 to 4. For glass or other transparent things, you don't want to go below 4 or your glass will not look right. A quick way to change multiple boxes at once in Blender is to left-click and hold down over the first one that you want, and then drag until the last one that you'd like to edit. If you release and enter in a value, then you can update for all of them at once. This works for any set of entries in any type of window. The maximum of 6 bounces with 4 per entry are Josh Gambrell settings. I use them and they work. Lastly, we'll come down to performance, and we're going to make one change. If you're using your CPU to render, keep the default tile size. If, however, you're using your GPU, change them to 256 by 256. Finally, we're going to go to the compositing workspace, and we're going to check the little box to enable nodes. These are similar to material nodes. Compositing allows you to make changes to your image after rendering without having to render again. I often use Photoshop or other software instead, but we specifically want to make use of denoising. To do that, simply hit Shift-A, go to Filter, and add in the Denoise node. From here, simply connect the image into the image, the denoising normal and albedo into their respective sockets, and then the output of the denoising node into the compositor. There are a few other compositing points worth mentioning. If you press Shift-A for output, you can add in a viewer. You can then connect your denoising node straight into here, and this will allow you to view your rendered image in the actual viewport. If you find that it's not taking up all the space that you'd like, simply come to View and then Fit Backdrop to available space. As mentioned, compositing can be used for final editing. I encourage exploring some of the options, though the most commonly used tutorial is the Filter Glare node set to a fog glow. Now we can finally hit render and make a note of how long this one takes. Note that the compositing effects will be applied automatically to the final image if you enable them before hitting render. You can also change them after and the render will update. For both Eevee and Cycles, to save the image, simply go to Image, Save As, and then select your preferred file settings and the location. As a quick comparison, it took just under 2 seconds to render this image in Eevee and about 34 seconds to render this image in Cycles. You can see there are some differences here, but for a simple figure such as this, you may actually be better off working with Eevee as it will give you a faster workflow, which is generally true, as I mentioned, for simple cartoons. Now that everything is done, what happens if you send your model to someone who doesn't have the HDRI, or the image textures, or something else? Well, they won't see it properly. Even if you use the built-in HDRIs, they might not be able to access it because the file paths won't be the same. To make sure all of that essential information transfers between users on different computers, go to File, External Data, and Pack All into .blend. This will make the file size considerably larger, depending on what you're including, but it means anyone can open the file as intended on different machines, something that is very important for teams or for anyone working on your projects in the future. If file size is an issue, I've found that Blender files tend to compress quite well. Now, I am a strong advocate for not reinventing the wheel. I also believe that scientific resources should ideally be free and open with minimally complicated licensing rights. I have and continue to release all kinds of free scientific models, and I have several videos documenting valuable science resources. Before you start trucking away at a complicated model or shader, see if someone else has made it first. Save yourself the time. I think Blender is absolutely worth learning if you're interested, but for the scientist, engineer, student, or professional that just wants nice figures, the hours and hours of 3D practice or work may not be worth the investment. There's absolutely zero shame in using pre-built things. Just make sure that you have the licensing rights sorted out, especially for journals. My general rule is to use CC0 when I create all of my own models to release to the public domain, and you can also find a number of other resources within the Blender community that are similarly licensed, such as HDRIs and image textures. So, with all that, what's next for you in Blender? Hopefully, making some figures. This was a long video, and I tried to pack it with a lot of information and tips that I've acquired through my experience, but this was by no means comprehensive. Still, don't let Blender intimidate you. It's actually a lot of fun, and you can make some really amazing figures with it. There is also an incredible community ready to support you. Blender's developers are always adding new features and fixing bugs. The artists who use Blender are a really tight-knit group, and the Blender Artist Forum, Stack Exchange, and YouTube community are filled to the brim with people who love the software and are often happy to help. The Blender scientific community, though a little smaller and a bit more niche, is also very extensive. If you want to see other great tutorial channels or videos, check out some of my community showcases, or the playlist on this channel titled Blender Tutorials for Scientists, where I gather all the Blender science tutorials I can find in one place. If you have a specific figure you need to make in a hurry, you're now well armed with the basics, and you might find what you're looking for already on this channel. Last but not least, these videos take a long time to make. If you stuck around to the end, thank you very much. I hope you enjoy Blender, and I'd love to see what you do with it. You can @ me on Twitter or Instagram at CGFigures. If this was helpful to you, consider subscribing, sharing with your friends and colleagues, and if you'd like, consider supporting me on Patreon. A major thanks to all of my existing Patreon supporters. You really help make this possible. And with that, as always, thanks for coming out, and I hope you have yourselves a great old day.